record to computer. Okay, so let us start. So today we move to chapter 2. Okay, about NumPy. So it's NumPy is a Python package, and it's short for numeric Python. Okay, and it's mostly used for scientific computing because it can handle large and multi-dimensional arrays and matrices. And its core data structure is ND array. So just remember, it just has this core data structure, ND array. So it's n-dimensional, okay? And also ND array, it is restricted to only store single data type. So this is also different from list, Python list. Python list is heterogeneous, okay? And also it says compared to Python list, it's much faster and use less memory, okay? And because list is also store sequence of data, so ND array also store sequence of data, okay? But we can see here that ND array is only used to store single data type. It's fast and use less memory, okay? And here it gives some features. So for ND array to operate efficient in both speed and memory. So later on we will see an example, okay, do the comparison. And also, so this is a key feature for ND array operation. So it's element-wise and vectorized approach, okay? And that's why it's much faster than using loops for Python lists. So like in math, we like to write this operation, is it? So some function apply to vector, is it? So kind of, like that kind of concept. It's vectorized, okay? And but for list, if you want to do something, is that if you apply some function to a list, then you need to use the for loop. Then you kind of like, so like for variable in sequence. Then you need to like use a for loop to pass in that loop variable to the function, is it? But we will see like for NumPy ND array, there is no such loop that needed. You can just directly call something like this, like in math, okay? But this function will operate element-wise, okay? So that's why it also says faster, okay? And why you can do that? It's because of some underlying implementation, okay? And we don't need to worry. And later on, we will also see ND array also supports variety of techniques for indexing and slicing, okay? And especially for indexing, there's a difference between NumPy array and list, because for Python list, you can only retrieve single item. But we will see for NumPy ND array, the indexing also support multiple items indexing. So here there's also broadcasting mechanism. Okay, so it allows element-wise operation on ND arrays. And broadcasting, it can also expand smaller array to larger array to match and then support some array operation. Okay, and here it also offers a list of some scientific computing functions like linear algebra and machine learning, okay, and the random number generation, and we will also see some of that. So this is just some concept. Advanced to, okay. And for installation, If you use Anaconda, then basically the NumPy is already installed, okay? But if you do manually individual packages, then you need to first install NumPy first. And then you can verify using this import statement to see if it's installed. And you can also testing with this very simple statement. Okay, so here it gives us some comparison because both used to store sequence of item. Okay, so NumPy's ND array versus Python's list. Okay, and it says regarding speed, faster because it does element-wise operation. For list, it needs to use loop. Okay, data type, ND array just single data type, so it's a homogeneous. But Python list is a heterogeneous. And the size for ND array, once it's created, you cannot change its size. But for list you can add new item. You can also remove existing item. So list, it can be updated. So that's just a very basic comparison, okay, between these two data structure. And so what we will start is how to create NumPy ND array, okay? So whenever you want to use NumPy, you first need to have this import statement. So import NumPy, import is a package, okay? And you can have this abbreviation and NP to represent NumPy. So we will see example, but first let's just take a quick look, okay, to create an ND array. So there are some functions you can call. So array function and some random function, random number generation function, arrange function, the link space function, zeros and ones, okay. So I will first go to our code example. I think it's yeah, so let's see. The coding part to create ND array, okay? So this is a very simple one. So you just call NumPy's array function and you plug in a sequence. So this sequence is a list, integer list. So then the array, it's a one-dimensional array. So this array will be array object will be created and it is assigned to this variable, okay? And you can do the instance check. If you recall last class, when we discussed class, we also make use of this function. So it checks if this variable is this ND array type, okay? And of course it is, yeah, but here just show us a double check. So the output it is, okay? And you can also see the output of the array. So it looks like a list, but it's not, because for list you have comma, okay? Here you don't. But it's also square bracket. If you don't have print, you just show this variable contents, then it also has an array ahead of it, okay, the output. But if you do the print, it will just directly go to the square brackets. And for array, it doesn't have comma separated them. So this is a pretty simple one, okay? So just an array function, then you can plug in some sequence. And next, so that's one-dimensional array. And next, let's see the two-dimensional array, okay? So for this one, two-dimensional array, what we pass in is a list of tuple. So here, within it, you have two items, and they are tuples. and it's a list, so sequence. So then in this case, it will generate a two-dimensional array. So it shows here. The data type is a float. You can also specify the data type with D type. So that's the output. So this is a two-dimensional array, okay? So this is, we call it row 1 and row 2. And here the second dimension. So that's the first dimension. So here's a column 1 and the column 2, column 3. So that's the second dimension. Okay, so this is regarding dimension. And generally speaking, in ND array, so you have the concept of dimension, the first dimension, second dimension, and later on we will also see like indexing and slicing and some other function. And you can also apply the axis. So axis is 0, that's the first dimension. So that's regarding row, okay? And so it's regarding row in this case, axis 1, then it's column in this case. Okay, because when you have multiple dimensions, then you just say row and column, that's not convenient. So normally we use axis. And then next, let's see, we can use a random number to also create a NumPy array. Then in this case, you need to use NumPy's random class, and it has a function called random. And this function, it generates uniform distribution, random number. And you specify the shape, it's 2 by 3. So 2 rows, 3 column, okay. And the random number generated is between 0 and 1 and half open, okay. So it lists here. And when you run this program, your number will be different from mine, okay, because it's a random number. And we can also call this a random n function, specify shape. Okay, so this is a standard normal and Gaussian distribution. So it has mean and variance. So it's different from the above. Okay, and then it's a two-dimensional. So for each dimension, you just specify, okay, the number of elements you want to have for each dimension. So both of the above two specify the number between 0 and 1, okay. And for the next one, yeah, it's normal. Then in this normal, then you can specify the mean and the standard deviation. And then you also specify the size. And this time for the size, you pass in a tuple, okay. Then it will generate, so it's 2 by 3. So that's what this array looks like. And the next one is this arrange function. So arrange, you specify the starting value and the ending value, but that's exclusive, not included, okay? And the step. So this is the step. So that's why the generated is 10, 15, 20, 25. 30 is not included, okay? And arrange doesn't need like the step always be integer. You can also specify with floating number, okay, with some decimal point. So this is starting, ending, and the step. And the linked space, this is different. This is the starting, ending number, and this is number of items you want it to be generated, not a step, number of items. So here you said I want to have 5 numbers generated. So you can use this function. And what the next one shows the zeros and ones. Because if you recall, in mathematics, we use a lot of all zero or all one matrices. So that's why NumPy also provide us the functions to generate all zero or all one ND array. Okay, because NumPy, one of the supporting is supporting the large matrix operation. It's efficient. Okay, because otherwise, if you use a list, it will be too slow. So then for this zero function and one function, then you just need to specify the shape. The shape uh, is provided as a tuple type. Okay. And if you want to get more attributes from the array, you can call like the shape. So shape will tell you each dimension and the data type, so D type, size, total number, and the dimension. So the above is two dimension, first dimension, second dimension. Okay. So next, what we will do today is we first go over of the coding. Okay, then we can come back to summarize the concept. And the next part we are going to discuss is NumPy basic operations. So we call it universal functions. And universal function, they are optimized function that is that operate element-wise. Okay, and previous I also mentioned it's vectorization. Okay, so the U function, what kind of, so here also give a list, some arithmetic operation. Okay, plus, minus, multiplication, division, and module. Okay, mathematical operation. So add, subtract, multiply, divide, and the power. Okay, trigonometric functions, logarithm functions, statistic function, comparison also, and the logic operation. Okay, so all of this they consider universal functions optimized. That's vectorized. Okay, and element wise. So let's see. After you learn NumPy, you say, oh, wow, yeah, much, it's much like you do some math. Okay. That's why I said NumPy support numeric operations, scientific numeric calculations. So let's go back to take a look at these two variables. What are those two variables? In the previous sections, we generated, is it random? Yeah, here are the two functions, or not the two arrays. So random ARR1 is a 2 by 3, 2 by 3 ND array. And random ARR2 is also a 2 by 3 ND array. Okay, so let's keep them in mind. Both are 2 by 3 ND array. Then here, did you see? If you want to add those two ND, basically in math, those two looks like two matrices. Like 1, 2, 3, 4, 5, 6, something like this. Is it in math? In math, you learn that like 11, 12, 13, 14, 15, and 16. You want to do matrix operation. So kind of similar concept, is it? And if you use a list, then you need to have the nested loop to do it in list. Okay. But here, did you see with ND array, it's a kind of, you just do like a math. Is it in math, you can apply like this is matrix A, then matrix B, then you just do A plus B, is it C equal? So similar concept, is it? So here you just do You see, just directly apply this plus operation directly to 2, that 2 by 3 in the array, ARR1 and ARR2. Okay, so this operation, why you can do it element-wise? Because the plus operation, it will directly do element-wise. So it will handle element-wise. We don't need to worry. Okay, you just write like what we do in math. So that's why we say it's convenient. Then similar, you see, when you, so this is just like, you know, like in math, you can also do this, is it? And here similar, okay, you add, then you just plug in that 2 in the array variable, okay? And the same thing, you can do sine and cosine. As it in math, you can also just do like sine. Is it something like that? Yes. Okay, cosine, is it? And log, similar. Okay, so all of this, why you can do that is because of element-wise. So the operation will automatically apply to individual. Is it? So like sine, cosine, log, it will automatically apply the operation to individual element. Okay, and also if you take a look, this is a comparison. It's also element-wise because it's a do element by element comparison. But when you write it, it's just to write the two array comparison. And here it's the array compare with a scalar. So this is called a scalar. So it also will do element-wise. So like 1 compare with 0, 2 compare 0, 3 compare with 0, each individual. And this where function we previously also learned, it's, this is NumPy's. Okay, previously we learned it's a different one. This is NumPy's, the filter, the where. It can do filtering. Okay, so what it does is do element-wise compare with 0. If it is less than 0, then it will go with this. Otherwise, it will go so the respective element, it will go with the second one otherwise. So that's based on if the condition is true or not. Okay. So this is a filter, and you can also calculate the overall mean about the whole array. Okay. So this is a concept and you can also see it's why we see it's efficient. Okay, compare with Python list because no loop is needed. There is no loop for all of those universal functions. Okay, so next in our example, we showed the comparison vectorization element-wise operation. Okay, and the conclusion is going to be magnitude faster than the regular loop. So let's see. So here we use that arrange to generate, so here is 1,000,000 items, numbers, okay? So you assign it to this array. And here you use that range. So this is Python's range, not NumPy. Okay, NumPy is a range. This is Python's regular range. Generate the 1,000,000 items and then plug them to the list. So you have a list generated. And here, this loop has nothing to do with the NumPy operation. Okay, this is just I wanted to do this operation 10 times. I want to do this operation 10 times because I needed to collect the time, okay, for the comparison. So this is to measure each operations, how long it takes, okay, to run this statement for 10 times. So for the first one, this is NumPy's multiplication operation. So this is element-wise. So this is vectorization, okay? And you collect time. And here is on my machine, it's wrong. On your machine, the time can be different because it's based on the physical, like CPU memory, okay? And then for list, the only way you see, so if we don't use loop, we use list comprehension, you still need to use a loop within the list comprehension, is it? Yeah. So then you see it takes this much of time. So if you compare these two, yeah, it's a huge difference, is it? So we can see NumPy it's much more. That's why we say it's much more efficient. It's not just in speed, it's also in memory, okay? Very efficient. So that's why it's also very good for scientific computing because the scientific calculation, a lot of time involve huge metrics. Okay, if we use a regular Python list, it will be very inefficient. The other major concept involved with NumPy is called broadcasting. Okay, so what broadcasting can be applied as smaller array, then can be expanded to match the larger array when it applies to the U functions. So those are universal operations, NumPy operation. Okay, so here let's take a look. So here we have a 2x3 array, and this is a one-dimensional array. And then you do this. Basically, that's not allowed. Even in math, you cannot do that, is it? But in NumPy, yeah, because of this broadcasting rule, it is allowed. So basically, what it will do is this one-dimensional array, then it will be extended to a two-dimensional array. So then it will be extended to this. And then you can add it to the larger array. The larger one, those are 2x3 now. Then it will apply that element-wise operation. Okay. So that's the concept here for the broadcasting. Then you can apply it. So even though the ND array shape is different, but then you can apply the broadcasting, so the smaller one will be expanded one to the larger one so that the operation can be applied. So the next concept is about indexing and slicing. And previously in a sequence, we learned indexing and slicing. Indexing in list and tuple is to retrieve single elements, okay? But over here, in NumPy array, we can also use it to retrieve multiple elements directly. Okay, so this is a very nice feature. And the slicing, similar concept, it's a subsequence. So yeah, next let's take a look at the indexing and the slicing example. So here we have a one-dimensional array. Okay, so it will be 10, 33. One-dimensional array. And then if you said here, I want to retrieve the third one. So this is 0, 1, and 2. So that's why you needed to use index 2 to retrieve it. And you can also do assignment. So then in this case, you assign 1, the second item to 15. So it will be changed. So the array will be changed to 15. Yeah. Oh, I'm sorry, this is not 3. This is a range, it's 10 and 13. Yeah. So every third, okay, I got it wrong. I'm sorry. So anyway, And then this one will be changed to -15. Okay. So it can also do assignment. And then here is the nice thing. This is needed to be careful. So this is this array. Okay. And then did you see within it, we plug in another NumPy array. So this NumPy array, so what this means, it means indexing for multiple items. So 0 means you want to get to the first. So this is 0. This is 1, 2, 3, 4, 5, 6. But if you recall, -1 means the last item, is it? So basically it will retrieve this one, and the last one. But of course, this already changed, okay? So that's why the multiple items is going to be this. So this is a way that you can retrieve multiple items. There's another way is you can also directly plug in a list. Using a list, that's also allowed. Array is allowed and list is also allowed. And then you can also retrieve the multiple index for multiple items, okay, from an ND array. In list, you are not allowed to do this. You are only allowed one item at a time. Okay, then for this one, so this is the array. The array, we have this sequence of items. And then next, what it shows, this is, we already learned with colon, and it's slicing. So slicing from the second item all the way to the 10th, okay? And every two, okay? So it's every two item. So this is 1, then 2, 3, 4, 5, 6, 7, 8, 9. But 9 is exclusive, not included. Okay, so that's how you have this sequence of items. And you have, when you negate, you can also use slicing to do setting, to set. Okay, because it's a slicing returns a shallow copy. So it can also be, basically the original will be changed. If you take a look, is it? So the original did get changed, change it to negative number. Yeah. So slicing, because why it can? Because it's shallow copy, okay, not a deep copy. And I don't remember if I ever mentioned the difference between shallow copy and the deep copy. Maybe I mentioned, I think I mentioned last class. Okay, so here it has a concept, it's a shallow copy, because view, the view concept is a shallow copy. So shallow copy basically in computer memory. So this is the original is an S array, and it has a bunch of items, is it? So when you do slicing, it's a part of it. So this is as that array, then 1, 9, 2. So part of it. Okay. So it's still point to the original array. So that's why it's called shallow copy. So even though you do something on it, so that's why original will also be modified. But if you do the copy, then what it means, so this eclipse part will be copied. So this is called deep copy. Okay. And deep copy, And if you do something, of course, it won't change the original, as it everything will only be on this clone. It won't impact the original. So that's the deep copy versus a shallow copy. And this one is also interesting, okay? Using negative index, then you can do reversing, okay? Quite useful small tricks to do reversing so that you don't need a loop, that you can just use negative indexing. Like in Java, C#, C++, you cannot do this. So that's a very nice feature. Okay, what's the next concept? It says three-dimensional array can be formed with two stacked two-dimensional array. Okay, and so basically, if you take a close look, it looks like two-dimensional, but here it's not. This is a three-dimensional. Okay, if you take a close look, you will see this is the outermost square brackets. Is it? And then within it, if you take another look, you will find, and then here you have comma, okay? And then here you have another pair. So, and then within it, you have the third pair, is it? So this is a pair, and within it, you have the pair. And you have the pair. Okay, so that's why this array is a three-dimensional array, okay, not a two-dimensional. So what's the first dimension? First dimension is this second level of brackets with the comma. So this is dimension, kind of like row. And within it, then you have, so within the first square bracket, you have another two square brackets. That's the second dimension. Same thing for the second one, you also have the two brackets. So that's the second dimension. Then third dimension, within each of this, you have column. So this is regarding the three-dimensional, okay? Then for this three-dimensional, let's see. We want to do some do indexing and slicing. Let's take a look. So here, that's your array. And because it's a three-dimensional, here you see you plug in with three integer numbers. And this is indexing. Indexing, because it's a three-dimension. So that's why you have comma separated. So this is regarding first dimension. And this is second dimension. And this is third dimension for the index. So the first dimension is the first one. So that's this chunk. And then second dimension is at the second one. So basically it's going to be this one. And the third dimension is 2. So 0, 1, 2. That's how you come with 17. You locate this item. Okay. So that's indexing for a single item. Previously, we already saw indexing for multiple items, is it? So how about this three-dimensional array? Let's also take a look. Okay, then let's take a look at this one. This first dimension is the second one. Second dimension is the second, so it's going to be this item. This one. The third dimension is an ND array. Is it 1 and 3? 1, 3. So that's regarding third dimension. Okay, third dimension is 1 and 3. So you're going to have an ND array be retrieved, okay, from the original one. Okay, so then in this case, you can see for the third dimension, it's multiple items. Indexing. Indexing, okay. So that's the idea here. And then next, let's see. What's the next one shows? Next one, if you take a look, first dimension, so dot, 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 just all items. Or later on, we will see including all colons, can be multiple, okay? But anyway, so that's just mean for the first dimension, everything will be included. Second dimension, colon, not starting, not ending by default. Then second dimension, also everything. Okay, so first dimension, everything. So everything. Second dimension, everything. So the whole chunk will be included for the first two dimension. Third dimension is 1, 2. Okay, so it will include this 2. This 2 color. Okay, so that's how you see the output. So it's a still 3-dimensional. Okay, and these 2 are equivalent. You can also write for the first 2 dimensions, you just use 3 dot. So the 3 dot also can be applied to include multiple dimension, everything. Okay, so first dimension both include everything. Then you can also just use dot, very convenient. And then let's take a look at the last one. The last one is as the first dimension, second dimension is, so this is the second, first dimension is 1. Second dimension, also this item. Then the third dimension is 1, 2. So 3 not included, so it will just this 2 item, okay. So here we saw how to use indexing and slicing to retrieve multiple items. Okay, very convenient. And next, let's see, the idea is also quite interesting. Okay, so you can also create, basically, you can also expand the dimension of the original array. Okay, so how do we do that? So here is a one-dimensional array, is it? And then regarding that, you say, okay, for the column, second dimension, I will keep everything. And first dimension, I'm going to create a row vector. So by insert a new dimension. So you can also insert a new dimension. You just do something like this with null, and then for the other dimension, you just include everything. Then what it looks like something like this. This is then a 2-dimension, okay? So it will be a 1 by 3, okay? Not a 1 dimension. The 1 dimension, it will be just 10, 20, 30. This is 1D array, okay? This is 2D array. So different, be careful. And you can also create it as a column vector by inserting a new column dimension. Then in this case, you keep all of the rows, and then for the column, you do the none. Then did you see it's a change? So this is a 3 by 1 2D array. Okay, 3 rows and 1 column. Next, a very important concept in NumPy is about fancy indexing. Okay, so let's see what all of this means. So here, this is a 2D array. 2D array. And then regarding this 2D array, if you take a close look, what's inside? So here you have a comma. So when you see the comma, that means the left is first dimension, right is second dimension. Is it? For the first dimension, okay, it tells us we are going to retrieve those listed items. For the second, we are going to retrieve from those position, etc. Then let's see, the first one, it's said first dimension is 0, so it will be from this row. The second dimension is also from the first column. Okay, so this pair we located, so it's 5. Yeah, so that's correct. And the second one, okay, it's 1. Second, and then it's 0, so it's going to be 15. So that's how we come up with this one. And then the third pair is 2 and 1. So 0, 1, also it's going to be this row. 2 and 1. 1 is 106. Yeah, so 106. And then the next one is 3, 2. So 3 is this one. 0, 1, 2. So it should be 117. Yeah, it's this one. And last is 3, 3. So last one and 0, 1, 2, 3. The 3. So 118. Okay. So here what it just shows us is it said you can select individual elements using list index for both axes. Okay. Then to pinpoint the desired element. So here we have the comma, as it is. So for each dimension, you can pinpoint. Okay. And what next one? The next one is plug in a list. Okay. So this is just regarding the first dimension because there is no comma for the second dimension. So only first dimension. So that's why I say that multiple rows. Is it? Okay, 1. This is 1. This is 0, 1, 2, 3. So, but 3 it repeat twice. Is it? So the result then will be yeah, it's here, the first one, and then it repeat. These two repeat. Okay, these two will repeat multiple times. And you can also do this. That's apply to row. Multiple row. And you can also select multiple column. Then for the first dimension, you just colon everything. Is it? Then in this case, okay. So this will be the for second column, and then third column 0, 1, 2, 3. The third column, you're going to repeat twice. Okay. So that's what you will have. And the next one what it shows us is, just be careful, okay? This is one part. This part is exactly the same as this one. So you just select sections from the original array, is it? But after that, you see, you can still do, so this part is rearrange. You can also rearrange an array using indexing and slicing. What here it says, okay, for the row, it keep the original, but the column, it will change. So this 19, 119, 119 will go first, okay? Then the third one, 0, 1, 2, 3. Then it's 18, 111, 118, 118. And then 1. So it's going to be 16, 116, 116. Then 2, okay. So 17, 117, 117. And then 0, okay, 15, 115, 115. So it's rearranged. So you can rearrange an array also, okay, using slicing and indexing. So that's why we call all of this fancy indexing. And what the next idea is, you can also using array of indices, apply it to a multi-dimensional array. Then you create a new array with a higher dimension. Okay, so this is a two-dimensional array. This is also a two-dimension, but serving as indicing. And the new one we will see is basically three-dimensional. Okay, so how do we do that? And here it also says the array of indices only apply to the first dimension. Be careful, okay? Apply to first dimension. Okay, then let's take a look. This example. So this is the original array, and this is the indice array, okay? And then you apply this indices array to the original multidimensional array. Okay, so what does this mean? Okay, this means for the new dimension, the first dimension, it will have first row, second row, and the third row. That's its first dimensions part. Yeah, did you see? That's what it comes here. And then for the second part, not to show. Okay. Okay. And then for the second part, it will be this one, 0 and 2, 3. This one and this one. So that's how you come up with this part. Okay, so then if you take a look, it's all the items are from the original one, is it? And basically, this array of indices kind of serve as location or position. Position is the first dimension for the new array. New array. Okay, so this new array, if you take a close look, it is a three-dimensional array. Okay, so yeah, you can use this technique to create a higher dimensional array. And what the next one try to show us is about Boolean indexing. Yeah, also very interesting. So this is a two-dimensional array. For this two-dimensional array, you apply element-wise operation. So this is element-wise operation. So you do module 2, okay? If module 2 is it, so that means all even number. Even number, is it? And the even number, then we can clearly see it's this column and this column, okay? And then, so what it returns is for the odd column, then they all have false. So it will have false, true, false, true, and false. And repeat for the remaining rows. Same shape as the original, okay? So this array is Boolean array, is it? Then you can plug it into the original array. So you basically just select for the even number, is it? Then you divide by 2. You can change the original array. So then if you take a look at the result, yeah, it did get reduced by 2. Okay, and then let's see. The next part. Yeah, that's it. In the real world, you may use this kind of operation, okay? Then let's see what we have the next. So here is a list. Here's a list. This first list is all string. Second list is integer number, is it? And if you take a look, here it's regarding that array. And what we want to do is, for the first dimension, you do slicing. Use slicing. And everything included. So the first, second dimension, let's see what this means. This is kind of a list comprehension. So it basically is going to generate a list, is it? Okay, so for ticker in this list, and if it is A, start with A. So you're going to have this one and this one, is it? So this will be true, this will be true, this will be false, this will be false, this will be false. So basically, you're going to have a Boolean indexing array be created. Okay, then you plug in this list comprehension. So Boolean index, or Boolean list. With the Boolean list, you plug into the ND array function. Then it will create a Boolean indexing array. Okay, with this Boolean indexing array, so that means, okay, so we have 5 columns. So you are only going to pick the true one, is it? So it's going to be this 2 column going to be created. Yeah, you can see sometimes, yeah, we can even borrow like a list comprehension from other list or some other data structure and do this kind of indexing or the slicing, okay? Then similar for the second part. And this is neat a lot of time, is it? Because sometimes you have value array and you have other kind of like title for your row and column. Yeah, for the second one, if you take a look, for this part, there is no comma, so it's all regarding first dimension. So for the first dimension, it's regarding this list. And for this list, module 10. So this module 10 division, module 10 remainder is 0. Module 10 with remainder 0. So then that's only this 2 year going to apply. So this is true, this is true, this is false, and this is false. Okay, so when you have this, okay, so you're going to apply first dimension. So this is going to be false. This is going to be true. And the last one is going to be true. So then you can also use this Boolean indexing to retrieve the respective columns. Okay, so that's the idea. You can combine even list comprehension, okay, into your indexing and slicing. So it's more flexible. And then next, yeah, this is also very, very useful operation, argmax. The argmax is to try to find the largest items index from largest item from each dimension, okay? So each dimension you can specify with the axis. If you recall previously, I mentioned that this axis. Okay, then let's take a look. So here is a two-dimensional array. And you call this argmax, and you plug in axis is 1. So what's it's going to compare that? So it will find the largest column, do row by row. So it will, so the compare will be all of the item from each column. So for the first row, it will compare. So this is the largest. Okay, so axis is 1. Axis 1 means you compare the item from each column. Okay. You compare item from column. And then for the second one, largest. Third one, largest. First one, largest. But it's index. So 0, 1, 2, 3, 4. So all 4. Is it? Yeah. So it will give you the index. Only give you the index, not the item. Okay. So you will find the index. And with that, you can basically locate where the item is. Then you can do what? So this is the second dimension because we have comma. So you do indexing with both dimension, is it? Okay, the first dimension, 0 and 4. So that's how you locate this. And the second dimension, 1 and 4. So you locate 19. And then you move to third row and the fifth column. So you locate them. So then in this case, you can locate the item. So you first use argmax to find the largest items index. And then you can build the index array to locate the item, the real largest item. So this tells axis 1 is compare among columns. If axis is 0, then it compare along the rows. So compare item from row. And same thing, then you can locate the item. Okay, so here, let's see, axis is 0, is it? So axis 0 is you're going to compare item from all rows and column by column. So among this is going to be the largest. So 0, 1, 2, 3. Okay, so 3 is going to be the largest, is it? And then you move to the second column. So 3 is the largest. Move to the third one, fourth one, fifth one. So their index are all 3, is it? So you find the index 1, 2, 3, 4, 5. So that's you come up with this year max index. With the index, then you can locate the item. Is it? Yeah, for each color. So it's always this row. Then for each column, you find the respective row. Okay, so then you can find all the largest items. So this is its argmax. And what the next one is also quite interesting. So this is ND array. We already know, okay, two-dimensional array. Here, this arg sort. So what this does is it does sorting along some specified axis, okay? So it does sorting. And what it return the index of the sorted elements from all rows. Okay. So let's see. So it's going to sort. So sort, for example, like the last column. Okay, so it's going to sort off the items from the rows. So then it's column by column, is it? So for this column, okay, after sorting, if in ascending order, it's going to be in ascending order, it's going to be 19, 109, 119, 209. Is it? If in ascending order, so sorted. So let's see the index. So 19 index is 1. 109, the index is 3. 119, the index is 2. And 209, the index is 0. Is it? So that's what this arg sort will tell you. Okay, the index, this part. So 1, 3, 2, 0. And then same thing, like for the first column, is it for the first column? So this is 0. And this is 1. And this is going to be the third one, and this third one. And this is going to be the fourth one. So here is 3 and 2. So the sorting index, and then for the same similar. So 0, and this is going to be the last, so it should be 3. And this is going to be so it should be 2. And this should be 1. Okay, so the sorted index, okay, similar, you can find like 7 and 8, the respective column, okay. And then let's see. So that's what you see, it gives. It gives you the index, okay, of the sorted one. But then how do you sort this this array? Is it? So you R sort, you will get this. Okay, you will get this, and of course you cannot sort all of them. For each column, you cannot. So you can pick a specific column. You say, okay, I'm going to sort following which specific column. So here it says, okay, I'm going to follow using this one to rearrange. Okay, and then if you pass it into this original array, then you can see it's rearranged. Yeah, then it's rearranged in descending order, because here is that not in ascending, it's a descending order, okay? Arranged by this column. So for the other column, it may not be arranged in descending order, okay? Yeah, so that's about the arc sort, also quite useful, okay? I think that's all for today. So we have some more. So we are going to discuss on Thursday. Okay. Yeah, that's all for today. So see you all on Thursday. Bye.